Hey guys, I hope everything's going good. Hope the long division and synthetic division went pretty well for you. Hopefully you found that stuff pretty easy and didn't have too much trouble. And if you did, hopefully you used your resources like your other students in the class, your colleagues, and other teachers that have said they'll help you. And of course the videos on the internet that I have given you to look at. So today we're going to talk about how to find rational zeros. What a rational zero means is it's real and it's not an irrational number, like it goes on forever, etc. So anyway, there's this formula that we can use called the possible rational zero theorem that helps us find all these potential roots. And remember, a root is where the function will cross the x-axis. So this theorem is going to help us to find all the potential zeros or roots or x-intercepts, and then we'll talk next time about how to figure out of those potential ones which ones are the correct roots. So I'm curious though, does anybody have an idea potentially of what might you look for? Anyone have a clue? We'll talk about it more next time, but basically it's whatever x values make y 0. So we'll talk about how to look in the calculator after you do the P and Q thing, which is what we're going to do today. So anyway, we first need to define what P and Q both are, because that's what we're going to use. The leading coefficient of your example or your function is called Q, and your lone constant is called P. And here's the process you're going to follow. You're first wanting to identify P, and then you're going to list all of its possible factors. So P, we see up here, is 6. So its factors could be plus or minus 1, plus or minus 6, plus or minus 2, or plus or minus 3. Because 3 times 2 would equal 6, and 1 times 2 would equal 6, just as well as negative 1 times negative 6 would equal positive 6. And negative 2 times negative 3 would equal positive 6. That's why we got to think about this plus or minus thing. Then we're going to do the same process to Q. So we know that Q is 3 from looking right here up here. It's with the leading coefficient. Remember, the leading coefficient is the variable that has the highest exponent. That's going to be your leading coefficient. So we know that 3 can only pretty much divide into 1 and 3. It's a prime number, so plus or minus 1, plus or minus 3. Now, what you're going to do on step 3 is to divide all of the factors of P by all of the factors of Q and list the quotients. So I have found that sometimes that gets a little overwhelming about, all the different combinations. So what I'll do is I'll list my set of P factors, 1, 6, 2, 3. So 1, 6, 2, 3, all divided by my first Q factor, which is 1. 1, 1, 1, 1. So this is kind of like my first kind of set, if you will. You could think of it like that, because all of these go with this denominator. And then I list my factors of Q, 1, 6, 2, 3, here again. But this time, I'm going to list them all with a denominator of 3, which is my second factor of Q. So I kind of find that easier to separate it and think of it like that. Now, some of the roots are going to repeat. So let's just go through here and see what it looks like. 1 divided by 1 is 1. 6 divided by 1 is 6. 2 divided by 1 is 2. 3 divided by 1 is 3. 1 divided by 3 is 1/3. 6 divided by 3, that's 2. I've already listed 2 right here, so I don't need to rewrite it. It's not necessary. Then 2 divided by 3 is 2/3, and then 3 divided by 3 is 1, which has already been listed. These are all the possible places this function could be crossing the x-axis. How many roots will it have for sure out of this amount? Does anyone know? I hope y'all are actually answering and trying to figure it out. It's going to have 3. The reason I know that is because it's a cubic function. The highest exponent on a variable tells us how many times it's going to hit the x-axis. Think about it. A quadratic hits twice, and it has the highest exponent of x squared. So this number right here, my leading coefficient, its exponent, so that 3, tells us what this number will be, how many times it will cross the x-axis. Okay, so let's move on and let's try one together. Okay, so now we need to list all the possible roots of this function. So first I want to identify p. This is p. So p equals 9, and all of 9's factors are plus or minus 1, plus or minus 9, and plus or minus 3. Because 1 times 9 equals 9, 3 times 3 equals 9. So now let's talk about q. Q's right here, so plus or minus 1, plus or minus 2, because 2 is prime, so it doesn't have any other factors or any other things that multiply to 2. Now I want to list, or excuse me, this should have been a 2, and go ahead and write these down here under factors. Now I want to do my listing of all my potential functions, or all my potential zeros. So I'm going to list my 1, 9, 3, and then divide all these by my first q, which is 1. Then I'll do again 1, 9, 3, and divide it all these by 2, which is my second factor. So all of these, plus or minus, 1 divided by 1, it's 1. 9 divided by 1 is 9. 3 divided by 1 is 3. 1 divided by 2, 1/2. 9 divided by 2 is 9/2. 3 divided by 2 is 3/2. So this plus or minus with the parentheses, the reason I did it that way is so whoever knows that this plus or minus applies to every one of these factors. So none of these repeated, but that's okay. This is our list. Okay, now I want y'all to try one. This one has a little bit of a trick in it, so make sure you try to catch it. It's in the very, very beginning. So let's go ahead and pause right here and give y'all a shot at this one. Okay, so for this one, I need to rewrite this in standard form. Because my negative 8x to the 4th, that is my leading coefficient. Because it has the highest exponent on it. So first, step 1, p equals negative 4. And its factors, plus or minus 1, plus or minus 4, plus or minus 2. Then I'm going to identify q, and q is my first number here, which is negative 8. And my factors are plus or minus 1, plus or minus 8, plus or minus 4, and plus or minus 2. So I'm going to have to do all of these divided by all of these. So first, so this is my p divided by q step. So I think the easiest way to do that is to just list all my p's and divide by my first q, then list all my p's again, divide by my second q, list all the p's again, divide by the third q, list all the p's one more time, divide them all by the fourth q. So I'm going to have plus or minus 1, 4, 2, all divided by my first root, which is 1. And then I'm going to have 1, 4, 2 again, all divided by my second cube, which is 8. Then I'm going to have 1, 4, 2 again, all divided by my third cube, which is 4. Then I'll have 1, 4, 2 one more time, all divided by my fourth cube, which is 2. Okay, so now it's time to actually list them. So just go through them from left to right. 1 divided by 1 is 1. 4 divided by 1 is 4. 2 divided by 1 is 2. 1 divided by 8 is 1/8. 4 divided by 8 is 1/2. 2 divided by 8 is 1/4. Now this one is 1/4. I've already got that. 4 divided by 4, that's 1. I've already got that. 2 divided by 4, that's 1/2. I've already got that. And down here, 1 divided by 2, already got that. 4 divided by 2 is 2. Already got that. And then 2 divided by 2, which is 1, and I've already got that. So that would be my final answer. Trying to give y'all a second to look at it. Okay, let's move on to the next section of today's notes, which is if I give you 1 0, how do you find the remaining zeros? Okay, so that means I've given you one root, and I want you to find the other roots, or one x-intercept, and I want you to find the other x-intercepts. So the easiest way to do that is to first synthetic or long divide out the 0 that I give you, and then you'll get a quadratic. Then you can solve the remaining quadratic by factoring or square root function or completing the square or quadratic formula. Okay, quadratic formula will work every time, but factoring, square root method, and completing the square, they only work some of the time. And completing the square honestly works all the time, but it gets really complicated, so it may not be something you want to do. So on this first one, the problem is f of x equals 3x cubed minus 4x squared minus 17x plus 6, and the root I've given you is x equals 3. Now I've not asked you to solve this root, it's already solved, so it's already x equals 3. So I started out doing synthetic division. I think it's easier. So you first write down all your coefficients from right here. So that's where my 3, -4, -17, and 6 came from. And then out here, I'm going to put my 3, which is my divisor. So I drag down this 3. 3 times 3 is 9. -4 plus 9 is 5. 5 times 3 is 15. -17 plus 15 is -2. And -2 times 3 is -6. 6 minus 6 is 0. So if I write this in an equation, and you should have this down from last time, your -2 goes with your constant, because this would be your remainder. So that means I don't have a remainder. And then your 5 goes with your x, and your 3 goes with your x squared. So given this quadratic right here, what's left, I chose factoring. I think it's easy. It made sense to me. I mean, if you did completing the square, you'd have to divide everything by 3, which that's not fun, because then you're working with some serious fractions. So I factored it, and I got 3x minus 1 and x plus 2, because 3x times x is 3x squared, -1 times 2 is -2, and -1 times x is -x, and 3x times 2 is 6x, and -1x plus 6x equals my middle term of 5x. So that's why this is correct. Then I split these up and set them both equal to 0. So I have 3x minus 1 equals 0. Solve for x by adding 1 and dividing by 3, so you get x equals 1/3. And this one you solve for x by subtracting 2. So x equals 1/3 and x equals -2. So all the zeros of this function are 1/3, -2, and the 3 from up here. So I have them written down here. And I've included a picture to show you graphically what's going on. -2 is right here, 1/3 is about right here, and 3 is here. So a cubic function kind of takes this shape. And that's about what you're looking at. Okay. So now I want y'all to give this one a shot. Start out by using either synthetic or long division to get the -2 out, and then solve the quadratic that's left. So let's go ahead and pause for a few minutes and let y'all give this one a shot. You can do it. I know you can. Okay. So first for my synthetic division, because I think synthetic's easier, I'm going to have 3, -4, -17, and 6. I have -2 on the outside. So I drag my 3 down. 3 times -2 is -6. -4 plus -6 is -10. -10 times -2 is +20. -17 plus 20 is 3. 3 times -2 is -6, and these go away. So my corresponding quadratic is 3, -10x, and 3x squared. So I'm going to solve this remaining quadratic by setting it equal to 0 and factoring it. Now I know that what goes in the front will come from this, 3x squared. So that will be 3x and x. I know that both of them will be minus, because this is a positive right here and this is a negative. So a negative times a negative is a positive, but a negative and negative added together is also another negative. It's going to be 1 and 3 like that, because -3 times 3x is -9x, and -1 times x is -1x. So -x minus 9x gives me -10x, which is what's in the middle up there. Okay, I want to set them both equal to 0. And solve. So all of my zeros are x equals -2, 1/3, and 3. This is actually the example from the last problem. We just factored out the roots in a different order. Okay, so these correspond to your homework pretty accurately. So it's time for y'all to get started. Hope y'all are being good and everything's going fine. Email me if you need anything. See you soon in next class. Bye-bye.